guys, so here we will be giving an introduction to visualization. Specifically, what I will be going into is I'll be trying to understand why graphs and plotting is important in the first place, as opposed to simply performing sort of test statistics on a data set, why we would want to sort of figure out what makes visualizations effective or ineffective, and we will be looking specifically at how to do this using several example graphs. And from those, we'll be trying to brainstorm how to design graphs which might better capture our analysis or message. So beginning with the first point, what I'll be trying to ask is the question, why graphs in the first place? And so for this, we will be using the iris dataset, which is taken from sklearn, which is a Python package. And specifically, what it has several measurements of various characteristics of iris flowers taken a long time ago. And so here specifically, my question will be whether or not there is a relationship between petal length in centimeters and petal width in centimeters. Here I've sampled sort of 5 points randomly from the data set for both of these variables. And so here we have a question, first of all, right? Is there even a relationship between these two variables? From this, it seems maybe there's a positive one, right? It seems that petal width is kind of small when petal length is small at 1.1. And meanwhile, when petal length is around 4, the petal width is similarly somewhere around 1, right? So perhaps there is a positive relationship, right? However, from this, we're not entirely certain whether or not it's linear, exponential, or logarithmic, or none of the above, right? So we don't know what kind of relationship this is necessarily. Further, we're not entirely certain from here what the range of our data is, whether or not there are maybe certain gaps in it, or whether or not specifically also how varied our data is. So we could have a bunch of clustering around a certain sort of variable range, right, within our data set. And we're not entirely certain from at least just like pure visual analysis of the data set, whether this is true, right? So for all of these, we could maybe just simply run some models, right? But I think it's a lot easier to get a grasp of all 3 of these questions, right? As well as the sub-questions for the relationship notion, right? Based simply on graphing the data set. And so for that, let's just do a simple scatter plot, right, of petal length and petal width. So we see, right, that there is distinctly a positive relationship from what we can tell of the data set at least, and it's somewhat linear. And also specifically, we know that there is actually a gap, right, as we noted prior in our questions. Between petal length 2 and 3 centimeters, we see basically no data. And that's fairly interesting, right? It means that basically if we had some sort of assumption that we drew uniformly also, that it seems that that would actually be a poor assumption, right? Because some data points seem to be clustered specifically around a smaller petal length and petal width, right? Specifically also further, it's kind of hard to tell initially from this scatter plot though, whether or not the data points are actually clustered because, well, we see the transparency changes, right? Specifically in the smaller like petal length area from 1 to 2 centimeters roundabouts, we see that there are like a lot of darker points. And I think this is actually because the data points are overlapping, right? And that's why the plot is just showing it as darker. But it's unclear to me, at least, exactly how many points are overlapping there. So one thought that I had was perhaps we should just bin based solely on the points. And so here we have a bin scatter plot in which specifically if the data point is exactly the same, we will just increase the size of the dot, right? However, my sort of first approach at trying to do this doesn't seem to be super successful, right? What we see here is we actually just have an even harder to interpret region between 1 and 2 because there seem to be a lot of dots around there. We're not entirely certain how many still because they overlap with each other, and so the size of the dot here is fairly hard to tell. So I update my estimate, and instead what I do is I do a bin scatter plot where specifically the count of the records is now being done over some bin size. So in this case, I chose a 0.5 centimeter bin of petal length as well as petal width, such that, for instance, if you have the dot between 1 and 1.5 centimeters for petal length, right? That big circle over there, it seems to be indicating a size of 20 specifically. And we see that there are essentially somewhere around 20 records, right? Between this sort of size range, which is fairly interesting. And I think gives you a more simplistic but better understanding specifically of how your data is actually being distributed. So this gives you, I think, all 3 of our questions. First of all, it shows you the range of our data set. It shows us the relationship as well. And further, it shows us specifically how our data is distributed in the first place, how varied it is. So our takeaways are that graphs can show the relationship between variables, the range and variance of the data set, and can also inform further analysis. For instance, here we note that we cannot make some sort of assumption here that there is some sort of uniform draw between a certain size range. And furthermore, we note that we can make our graphs more intricate or more simplistic for our use case. If we simply want to see all of the data, we can maybe use our first scatter plot, which just plots them directly. And if we would like to understand the range and variance as well, we maybe would like to use some sort of binning. So now we will move on to sort of understand what specifically can make some visualizations more effective or more ineffective. And I will be doing this based on a fun little section called Not That Graph, a caveat that this is only used to analyze the graphs. And I'm not really sponsoring any of the views that are taken within these graphs. So first of all, we have a Fox News discussion regarding what happens if the Bush tax cuts expire regarding the tax rate of the top tax rate. And you see here that what they say is they say that if should the tax cut expire, it will rise from 35% to 39.6%. And Fox specifically shows this as a very large increase due to zooming in on the range of the graph. You see the graph goes from 34 to 42% in the y-axis. However, as we all know, this really seems to be a super zoomed in view to show the change. But if we took the y-axis from 0 to 42%, for instance, it would feel like a much smaller difference. So here, what Fox is trying to convey is they're trying to make this sort of larger than it is, right? Which distinctly seems to be a misrepresentation of the data. So I think it's something always to be aware of with regards to how you choose the range of your data in this case. So further, we have a graph from The Mail, which is a British newspaper, and they show essentially a critique of global warming data, where specifically what they use is they use the change in temperature and note specifically where our average temperature falls with regards to predictions of world temperatures. And specifically here, what The Mail is trying to note is they're trying to say that sort of climate scientists are not being particularly good with their data in the first place, and that their degree of uncertainty is super high and they aren't predicting the world temperature well. What this graph doesn't note, right, which is something unfortunate, is that the world temperature data isn't really a note for global warming in the first place, a good measurement of it specifically. And so that actually is not a useful graph to represent their claim, which was that global warming is not necessarily an appropriate assumption or theory, essentially. And so here, we first note that our data set is inherently flawed, as well as we would like to note that basically the notion here of these degrees of certainty or uncertainty actually just like may in fact like be somewhat uninformative due to the fact that temperature is inherently a noisy measurement, right? And having it fall within this degree of certainty is still, I think, a credit to these climate scientists. So here, I think the issue is specifically something with our data set, how we actually want to represent something different to actually ascertain whether or not global warming claims are accurate or inaccurate. And now finally, we have a graph, which unfortunately the title is cut off from. This is regarding the European Parliament composition. And this was a graph made by Business Insider. Specifically here, we have a 3D pie chart. And the 3D pie chart here is supposed to represent the composition of all the individuals in the European Parliament, what parties they represent specifically. And so the major issue, right, is as a 3D pie chart, it is kind of hard to tell what the orange slice, how much bigger the orange slice is, for instance, than the blue slices. Also, specifically here, the color scheme is incredibly hard to interpret. We have two blues here, we have two reds here. I'm not entirely certain why they're separate, for instance. So I think there are a lot of issues. The first and major issue, I think, is 3D pie charts cause you to have a very poor perspective on how large certain things are. And since it's not labeled, you can't necessarily tell, right? Which makes it very hard to read. A second notion is that I think there might just be a lot of parties involved, and because of that, the color scheme is very hard to interpret as a legend. So our takeaways are specifically that we would like, first and foremost, to make sure our graph actually conveys what we want it to, but two, when trying to do that, we should not misrepresent the data, as we saw in the Fox News graph. Three, we would like to keep it simple, which is something that we saw was an issue with the pie chart. And finally, we should always be aware that graphs may not actually capture all the relevant data, as we saw in the Mail chart regarding sort of the temperature analysis. So basically, in sum, there are many sort of things that we would like to be aware of when regarding graphs, both sort of even before we make the graph regarding the data, as well as when we make the graph, whether or not it is actually sort of morally sound with regards to how we are representing the data, as well as actually accurate and conveying what we would like it to convey well. So finally, we would like to take these sort of graphs that I just gave you before, and I would like you to sort of redesign them potentially to best capture their message. So we have the section now, change that graph. Again, we were using the same graphs as before. The views are not sponsored. So first and foremost, what can we change? So preliminarily, we can always change the data, right? This is something that we would specifically want to note for the mail data and the graph surrounding it, because specifically, we always want to make sure the data we use is actually able to convey the message we would like or the analysis we would like to perform. So going forwards, we can change the graph style. We can use a bar plot or a line plot or a pie plot or something even different, right? We can always use something like a violin plot if you would like to be more, cool and stylish. There are a ton of plots out there that you can use, and we will go into that in further classes. But specifically here, I guess I would like to focus on these three as they're sort of fairly simplistic and things that we should have all encountered before. We can change whether or not we bin or don't bin the points in the graph, which can be used to basically simplify the graph if we need to, as we saw in our first example of the scatter plot that I did. We can also include error bars potentially, right, as we saw actually in the mail graph, and that's actually fairly useful. So this is more for if you have a prediction of a certain variable, and that prediction usually comes with some sort of error or uncertainty regarding the prediction values, right? And including that can definitely help people understand that this is still like a fairly like, either it is actually a very good fit and you have like very little error or uncertainty, right? Or you have a lot and that's fair enough, but I think it's good always for the public or for people just viewing the graph to be aware of that. And finally, we can also change the graph range, right? We can narrow the view if we genuinely think that that is still an appropriate and formation of the data, as well as something that would maybe help our analysis a bit more, or we can widen it out such that we make sure that people have an informed view of what this data represents. So specifically here for our first sort of bar plot that we examined regarding the tax cut increase or the increase in taxes should the tax cuts expire, right? What we would probably want to do is we want to, in this case, zoom out, right? We want to actually view this, right, from the tax cut or the tax being at 0% to, in this case, I guess 42%, right? I think that'd be a much better representation. I think that keeping it as a bar plot in this case is fine, right? Since we actually just want to compare two specific values at two specific times that are unique from each other, right? We'll go more into exactly what graphs to use where, but just as a caveat that I think the graph choice here is fine. I think the main thing here would probably be to zoom out. And moving forward, we noted here in the mail graph that we'd actually just want to entirely change the data. But suppose we had something that was more representative, such as, for instance, the ozone layer, right, and its deprecation over time. So I think that scientists specifically are also measuring this and having some sort of fit regarding that. So I think a line plot would still be fine for such representation, as well as some uncertainty regarding that. Specifically, the thing to note is that the mail graph here, I think, is somewhat sound with regards to how it is choosing to represent the data. And so you can take it as a fairly good example of this. It's pretty easy to read, for instance, as well as it doesn't seem to be like zooming in too closely as done in the Fox News case. However, a thing to note is here you would actually just want to change the data and try to analyze a different data set entirely. And finally, for the Business Insider sort of 3D pie chart case, first of all, I think the initial thought is just to not make it 3D. I don't think there's any point in making a 3D pie chart, frankly, since it's just harder, I think, for most people to analyze, though I guess it does look prettier, potentially. So up to you, I suppose. But definitely something to note would be you should probably include percentages here, especially since you have far more than like 4 or so parties. And it's always good just to have that as a frame of reference for people who would like further viewing. Something else to note would be, I think, the choice of color scheme here is a bit poor. You ideally want to make it such that all portions and slices of the pie chart are instantly recognizable as a certain party. And it might be better actually to just label the sections of the pie chart directly on the pie chart itself rather than having a separate legend, as I think moving from left to right continuously to try and figure out which color represents what is a little bit hard. So I think these are some of my suggestions for all three of these graphs. Obviously, if you have others, feel free to send them back to me actually, but like otherwise, I think it'd be good to discuss with just internally or with friends regarding what specifically you would maybe want to do to change these graphs. So to wrap up, we'd note that graphs are pretty powerful tools, right? Obviously, all the graphs that we saw tried to make some pretty important points, right? Or otherwise show some interesting analysis. But we must use them well, right? Because otherwise we misrepresent our data, or we maybe just don't convey the message we would like to. And we also further note that certain graph styles are better suited to certain messages, right? Which we will go actually into further. But preliminarily, we saw that like the choice of a bar plot or a line plot or a pie plot definitely seemed to be suited to the kind of data that they had. And further, I think we would also just want to emphasize the notion of considering the data in addition to the graph, right? Because it's always important to think of them sort of as a pair. Specifically here, we want to make sure that the data we use is good, and we want to make sure the graph that we use fits the data.